Hello friends, my name is Mittal Gada and today we are going to learn Geometry, Mathematics Part 2 of Standard 10. This is the most unlike subject among the students. But believe me, if you see all my videos, you will surely like this subject and get at least 35 marks from 40 marks in your exams. Okay, if you liked my video, please don't forget to like, subscribe and share so that you don't miss out any videos. So, let us get started with the first chapter of mathematics syllabus, that is similarity. Let us now see what are we going to learn in this chapter. In this chapter we'll be learning ratio of areas of two triangles, basic proportionality theorem, converse of basic proportionality theorem, tests of similarity of triangles, property of an angle bisector of a triangle, property of areas of similar triangle, and the ratio of the intercepts made on the transversal by three parallel lines. In this video, we'll be dealing with ratio of area of two triangles, basic proportionality theorem, converse of basic proportionality theorem, property of angle bisector of a triangle, the ratio of the intercepts made on the transversal by three parallel lines. We'll be dealing with tests of similarity of triangle and property of areas of similar triangle in the next video. Please remember, I am just teaching you the concepts in this video. I will be making another video where I'll be solving each and every sum of the exercise. So if you like this video, please like, subscribe and share so that you don't miss any videos. Okay, so let us start with the first concept, that is ratio of areas of two triangles. Let us understand word by word. Okay, now let us see what do you mean by ratio. Everybody knows what is a ratio. Let us first take an example of ratio. Correct. Can you see an example of ratio on the screen? Yes. A is to B, which is also called as A upon B. Let us take one more example of ratio. 5 is to 7, which is also written as 5 upon 7. So looking at these two examples, can we say that ratio is equal to something upon something? Ratio matlab you have something in the denominator and something in the numerator. Okay, having known what is ratio, let us see what is area of a triangle. You all have already studied in your lower standards area of a triangle. Let us revise it fast without wasting any of our time. Area of a triangle is half into base into height. Remember, height is always perpendicular to base. Now, here we will take an example of a triangle and y'all will tell me what is base and height of that triangle. So let us take two examples of triangle. Right now, we'll only concentrate on the first triangle, that is triangle ABC. Now, if you look at triangle ABC, can you all tell me what is the base of this triangle ABC? Yes, correct. BC is the base of triangle ABC and AD is the height. So what will be area of triangle ABC? Half into base, which is BC, into height, which is AD. Now let us find the area of triangle PQR. Okay, can you all tell me what is the base and height of triangle PQR? Correct. QR is the base and PS is the height. So what will be area of triangle PQR? It will be half into QR into PS. Having known what is ratio, what is area of a triangle, let us now derive the formula of areas of ratio of areas of two triangles. Okay, now if you want ratio of areas of two triangles, first you will need two triangles. So let us take two triangles first. Okay, now we want ratio of area of first triangle upon ratio of area of second triangle. Means I want in the numerator area of triangle ABC, and in the denominator I want area of triangle PQR. Correct. So now first, before writing what is ratio, we'll first describe both the triangle. So in triangle ABC, AD is the height and BC is the base. Similarly, we'll describe the second triangle. In triangle PQR, PS is the height and QR is the base. Now we'll write down ratio. So how will we write? Area of triangle ABC upon area of triangle PQR will be equal to, in the numerator you will write area of triangle ABC only, and in the denominator you will write area of triangle PQR. Means if you are writing in the numerator ABC, तो वही ABC ट्राइंगल का ही बेस और हाइट लिखना है, और अगर डिनोमिनेटर में PQR लिख रहे हो तो PQR का ही बेस और हाइट लिखना है. ओके अगर अभी हम ये इक्वेशन देखेंगे तो यहाँ पे न्यूमरेटर और डिनोमिनेटर दोनों में हाफ हाफ है, तो ये हाफ हाफ कैंसिल हो जाएगा. तो हम लोग को क्या मिलेगा? एरिया ऑफ ट्राइंगल ABC अपॉन PQR इज इक्वल टू BC, which is the base, into AD, which is the height, QR, which is the base, and PS, which is the height. So it will be base into height of triangle ABC upon base into height of triangle PQR. Means area of, hence we can say that ratio of area of two triangle is equal to base into height of the first triangle upon base into height of the second triangle. So if we denote the base and height of first triangle as B1 and H1, and base and height of second triangle as B2 and H2, then what formula we'll get for ratio of areas of two triangle will be equal to base into height upon base into height. Now students, whenever you think any important formula is been coming up in this video, just take your books and pen and write down. Or whenever you think that I am going too fast, pause the video, understand the video, and then continue with the video. Clear? Now, next we will see what will happen if the heights of the triangle are same, and what will happen if the bases of triangles are same. So let us take first condition first. Means if the height of the triangles are same or equal, what you say as. So for understanding this concept, let us take an example of two triangles. Okay, now you can see two triangles in your screen, that is triangle ABC and triangle PQR. Okay, now even you can see that both these triangle have height as h, means both these triangle have same height. So let us see what happens. Area of triangle ABC is equal to base, which is BC, into height, which is AD, which is denoted by h, and area of triangle PQR is equal to base, which is QR, into height, which is PS, which is denoted by h. So now if you look at this equation, height is there in the numerator also and denominator also. So this height will get cancelled. Therefore, ratio of area of two triangle having equal height is equal to their corresponding bases. मतलब अगर दो ट्राइंगल की हाइट सेम होगी तो वो दोनों ट्राइंगल का रेशियो will be equal to their corresponding heights. करस्पॉन्डिंग मतलब क्या? जो ट्राइंगल हम लोग ने न्यूमरेटर में लिखा है उसी ट्राइंगल का बेस लेंगे हम न्यूमरेटर में, और जो ट्राइंगल हम लोग ने डिनोमिनेटर में लिखा है उसी ट्राइंगल का बेस लेंगे. सो व्हाट विल बी एरिया ऑफ ट्राइंगल ABC अपॉन ट्राइंगल PQR will be equal to H1 upon B1 upon B2. Why? Because the heights are same. So this is the property which we came across when the heights of both the triangle are same. Yes. the ratio of the areas of two triangles with equal height is equal to the ratio of their corresponding bases. This word corresponding is very important because तुम लोग जो न्यूमरेटर में लिख रहे हो उसी का बेस तुम लोग को न्यूमरेटर में लिखना है, जो डिनोमिनेटर में ट्राइंगल लिख रहे हो उसी का बेस तुम लोग को डिनोमिनेटर में लिखना है. Okay? Having learned that the ratio of areas of two triangles having same height is equal to the ratio of their corresponding bases, now let us see when can two triangles have same height. For this, please look at the figure which is shown in your screen. Now only concentrate on triangle A, that is the red triangle. Students, can you tell me what is the height of this triangle? Yes, students, this yellow line is the height of triangle A. Now, consider triangle B, that is an obtuse angled triangle. Students, can you tell me the height of this triangle B? Yes, correct. This yellow line is again the height for the triangle B. So, now can I say that both these triangles, that is triangle A and triangle B, have same height? Yes. So, what did we conclude from this? That whenever we have two or more triangles wherein their vertices are common and their heights are lying on the same line, then their heights will be same. Yes, students. जब भी आपके पास दो या दो से ज्यादा ट्राइंगल हो जिनके वर्टेक्स कोई भी एक वर्टेक्स कॉमन हो और उनके बेसिस अगर एक ही लाइन में हो तो उन सारे ट्राइंगल का हाइट क्या होगा? सेम होगा. हाइट विल बी सेम. To understand this concept more clearly, let us consider one more example. Now, if you look at this figure, you have so many triangles in this figure. If I take this triangle, that is triangle ABP or triangle APD or triangle ADC or even a bigger triangle that is ABD or ABC, all these triangles are having a common vertex, that is A, and their bases are lying on the same line. Therefore, we can say that for all these triangles, the height will be same. Let us consider one more figure. Now, if you concentrate on this triangle or on this figure, you have how many triangles? Three triangles, that is triangle CAM, triangle CMB, and triangle CAB. All these triangles are having a common vertex C and their bases are lying on the same line. Therefore, the heights of all this triangle will be same. Similarly, we'll consider one more example. Even in this figure, all the triangles, are having a common vertex B and their bases are again lying on same line. Therefore, the heights of all this triangle will be same. So what we came to the conclusion that whenever you have triangles which have a common vertex and all those triangles have a base which is lying on the same line, then their heights will be equal. Okay, then their heights will be equal. Please repeat after me. If triangles have a common vertex and their bases lie on the same line, then the height of the triangles are equal. So what did we see? When can heights be same? First one, when it's already given in the question that the heights of both the triangle are same. Second, when we have a common vertex for the triangles and their bases are lying on the same line. Now we'll see one more condition. When can heights of two or more than two triangles be same? For this, now let us see. Let us consider two triangles first, this yellow and a red one. Now let us try to draw two parallel lines. Okay, 1 and 2. Can you all tell me, students, are these two triangles lying between these two parallel lines? Correct. Yes, they are lying between these two parallel lines. Now, if I try to draw a perpendicular from this vertex for this triangle, it will be this. And if I try to draw a perpendicular for red triangle from this vertex, then again this line will lie between these two parallel lines. Means the height of both these triangles are lying between two parallel lines. And we have already learned that whenever we draw a perpendicular line between two parallel lines, they will always be same. So we came to the conclusion that whenever we have triangles which lie between two parallel lines, then their heights will be same. मतलब जब भी हमारे पास दो या दो से ज्यादा ट्राइंगल्स होंगे जो दो पैरेलल लाइन के बीच में हो, तो उन दोनों ट्राइंगल या कितने भी ट्राइंगल्स है उन सब की हाइट क्या होगी? सेम. To clear this concept, let us take one more example. Okay, now in this example, that is figure 1.15, we have so many triangles. Okay, now if I consider only triangle ABC and triangle DPC, can you all tell me, students, are these two triangles lying between two parallel lines? Yes. Therefore, both these triangles will have same height. So, ratios of these two triangles will be what? Will be equal to their corresponding bases. So, let us fast revise when can heights of two triangle be same. So, heights of two triangle can be same in three conditions. When it is already given in the question that their heights are same. Second, when they lie between two parallel lines. And third, whenever two or more triangles are having a common vertex and their bases are lying on the same line, then their heights will be same. Having seen when can heights of two triangles be same, let us see now when can bases of two triangles be equal. अगर हम लोगों ने देखा अगर हाइट सेम है तो उनके रेशियोज, दो ट्राइंगल के रेशियोज क्या हो गए? विल बी इक्वल टू देयर करस्पॉन्डिंग बेसिस. तो अगर बेसिस सेम है तो उनका रेशियो क्या होगा? दो ट्राइंगल का रेशियो क्या होगा? विल बी इक्वल टू देयर करस्पॉन्डिंग हाइट्स, क्योंकि बेसिस तो सेम है. तो क्या होगा? एरिया अपॉन एरिया विल बी इक्वल टू हाइट अपॉन हाइट. पर कभी सेम हो गए. दिस इज वेरी इजी एंड यू ऑल विल अंडरस्टैंड इट वेरी फास्ट. So if you concentrate on this figure which is shown in your screen, just concentrate on triangle which I am showing. If you see triangle CAB and triangle PAB. Okay, now both these triangles are having same base, that is AB. Okay, now if you consider triangle CAB, can you all tell me what is the base of this triangle? AB, correct? And if you all consider triangle PAB, what is the base of this triangle? Again AB. So, is the base of both the triangles same? And heights are already given, that is H1 and H2. So, if we write down area of triangle CAB upon area of triangle PAB, so it will be equal to what? Base into height upon base into height, which is AB into H1 upon AB into H2. So AB will get cancelled. So what you will get as the answer? Area of triangle ABC upon APB is equal to H1 upon H2. Why? Because their bases were same. So which property we came across? That whenever the ratio of areas of triangles, two triangles with equal bases, is equal to the ratio of their corresponding heights. Students, please be careful about this word corresponding. If you are writing some triangle in the numerator, then you will have to write the basis and height of that triangle only in the numerator. And the basis and height of the triangle which is written in the denominator will go in the denominator. Please don't get confused in this, because I have seen many students getting confused. So if you are writing some triangle in the numerator, वही ट्राइंगल का हाइट तुम न्यूमरेटर में, हाइट या बेस जो भी चाहिए वो न्यूमरेटर में रखा. दिस इज द इम्पोर्टेंस ऑफ द वर्ड करस्पॉन्डेंस. Okay, now we have already seen the conditions when can height be same, when can bases be same. Take one more example, when can base be same. Now if you look at this triangle, that is CAB, and triangle DAB, both these triangle have a common base, that is AD. Then what will be ratio of areas of these two triangle? Will be equal to their corresponding bases, that will be BC upon AD. Okay, so now let us further continue. Now we will be learning a very important chapter from your exam point of view, not chapter, a concept or a theorem from your exam point of view. That is Basic Proportionality Theorem. Okay, before starting with a theorem, as we are dealing or as I am explaining you the theorem for first time, let me tell you the important steps of this theorem. First step will be statement. Second step will be to draw a figure. You will have to draw a figure with the help of the statement. In the exam, only the statement will be given to you. You will have to draw the figure. So first step will be you will have to draw a figure. Thereafter, after drawing a figure, you will have to write given. Then you will have to write to prove. Then you will have to write constructions if any, and then you will have to start with the proof. So while explaining you this theorem, I will go step by step. So what does the statement of this basic proportionality theorem states? What does it say? That if a line parallel to the side of a triangle intersects the remaining sides in two distinct points, then the line divides the side in the same proportion. So now with the help of this statement, let us try to draw a figure. What are they saying? If a line parallel to side of a triangle, so we will need a triangle first. So students, take a book, pen and draw a triangle first. Now for this theorem, I will let you draw the figure first and then I will draw the figure on my screen. So first draw a triangle. Okay. After drawing a triangle, make a line which is intersecting the other two sides of the triangle and is parallel to the third. मतलब जो दो लाइन को वो इंटरसेक्ट कर रही है उसके ऑपोजिट जो लाइन है तीसरी लाइन को पैरेलल होनी चाहिए ये लाइन. ठीक है, तो देखो आपका फिगर और ये फिगर मैच हो रहा है. यस, तो क्या करना है आपको, एक ट्राइंगल बनाना है ए बी सी, और ये लोग जो लाइन की बात कर रहे हैं ना, दिस लाइन, दिस इज लाइन एल, दिस लाइन शुड इंटरसेक्ट टू साइड. इज इट इंटरसेक्टिंग टू साइड ए बी एंड ए सी? या, दे आर इंटरसेक्टिंग एट पॉइंट पी एंड क्यू. And is it parallel to BC? Yes, we have to draw like that only because this is given. So with the help of this statement, we will write down what is given and to prove. Acha, whatever is there after if will become your given, and whatever starts after then will become your to proof. So with the help of this statement, can you tell me what is given? Yes, what is given? That this line L is parallel to this side BC. So first, how do you describe? See, geometry is an art. If you don't write as per steps, you will lose your marks. So whenever you are writing a geometry paper, please write stepwise. Means you have to describe each and everything. You have to describe a triangle, you have to describe which line is parallel to which side, X, Y, Z. So what we will write in our given? In triangle ABC, line L is parallel to line BC. And line L is also intersecting the other two sides, correct? Which two sides? That is AB and AC. At points what? P and Q. So this will become our given. Now what we have to prove? Let us concentrate on the portion of the statement which start with then. Then the line divides the sides in the same proportion. What are they saying? They are in proportion. Proportion means again in these two. Agar for example this line, that is line L, is dividing side AB and side AC. correct? So you have to say that this segment upon this segment is equal to this upon this. So what will be your two proof? AP upon PB is equal to AQ upon QC. So in BPT you have to prove that AP upon PB. So students, having seen what is given, what is to prove, let us start with the proof of this theorem. Okay. Now for starting the proof, let us concentrate on the left hand side of to proof. What is there on left hand side of to proof? AP upon PB. What is that? AP upon PB. Students, tell me, where can you see segment AP upon AP and PB in the figure? Yes, correct. Where can you see? AP upon PB. AP upon PB. Okay, now for solving this, we will be using all the formulas or all the theorems or all the concepts which we have learnt earlier in this chapter. So just recollect, when can you get AP upon PB? When can you get AP upon PB? We have seen whenever the areas or whenever the bases of two triangles are same, then their ratio will be equal to their corresponding heights. And if heights of two triangles are same, then the ratio will be equal to their corresponding bases. Okay, now look at segment AP and PB. What can you say about these two segments? Do they look like height? No, they don't, because they are not perpendicular to any side. Okay, so can I say these will be the bases? So we want two triangles whose height are same, so that the ratio of those two triangles will be equal to their corresponding bases, which is AP and PB. Okay, so now just look at segment AP and PB. Do you have any triangle which is part of these two segments? Yes, you have one triangle, but whereas you don't have another triangle. So that's the reason we did this construction. That is, we have joined B and Q so that we get a segment BQ. So now can you see two triangles? Yes, you can see two triangles. So now you can get left hand side of your two proof, which will be area of triangle APQ upon area of triangle QPB will be equal to AP upon PB. What will be the reason? Because these two triangles are having a common vertex, which is Q, and their bases, that is AP and PB, is lying on the same line. Therefore their heights will be same. So what will be the construction? Join P and Q. Similarly, if you look at the left hand side, you want AQ upon QC. Again the same logic will apply. This you have to make base of two triangles. You have one triangle but you don't have another triangle. So that's the reason why we are joining PC. So what will be your construction? Construction will be draw segment PC and segment BQ. Okay, now we have already seen how you will get your left hand side and right hand side. So first concentrate on these two triangles. So what you will write? Yeah, triangle APQ and triangle PQB have equal heights. Why do they have equal heights, students? Yes, because both these triangles, that is APQ and QPB, both these triangles are having a common vertex Q, and their bases AP and PB are lying on the same line. Therefore their heights are equal. So what will be the ratio of the areas of these two triangles? Will be equal to their corresponding bases. So what you will write? Area of triangle APQ upon area of triangle PQB will be equal to AP upon PB. And what will be the reason? Areas proportionate to bases. Similarly, with the same concept, we will write what? For triangle APQ and QPC, both these triangles are having a common vertex P, and their bases AQ and QC is lying on the same line. Therefore their heights will be same. Therefore the ratio of area of these two triangles will be equal to their corresponding bases, and the reason will be areas proportionate to bases. See, remember students, whenever you are writing this theorem, it is advisable that you write the entire statement. Which statement? That these two triangles are having a common vertex and their bases are lying on the same line, therefore their heights are equal. If you write this entire statement, your chances of losing marks are very low. But this is the same way it is there in your textbook, and that's the reason I have written like this. Okay, so now just concentrate on this two. Okay, if you look at this part, this is what we want in our left hand side of 2 proof, and this is what we want in the right hand side of 2 proof. We don't want this part. Okay, so what happens if we prove both these right hand sides equal? Then you can say that these left hand side will be equal to this left hand side because their right hand sides are equal. So let us check one by one all these triangles and see what can we do of these triangles. Okay, now look at triangle APQ. APQ. Okay, this is in the numerator. Now look at the second equation which is there in the numerator. APQ. Again APQ. So can I say in both these equation numerators are same? Okay, so we are done with the numerator. Let us see the denominator. Okay, look at triangle PQB. PQB. Okay, look at triangle PQB. Okay, now what is there in the second equation in the denominator? PQC. Now look at triangle PQC. PQC. What is it? PQC. Okay, now look at these two triangles. What are they saying? Which two triangle? PQB and PQC. Okay, these two triangles is having a common base that we can see. One more thing, these two triangles are lying between two parallel lines. So what have we learned, students? Whenever triangles are lying between two parallel lines, their heights will be same. So for these two triangles, heights are also same, bases are also same. So what will be the ratio of both these triangles? Okay, can we say the ratio of the areas of both these triangles will also be equal? Why? Because their heights as well as the bases are same. Let this be written as equation number 3. Now look at equation number 1, equation number 2 and equation number 3. Okay, now numerators are already same because both are the same triangle. Denominators also we proved it same in equation 3. So now from all these three equations, that is equation number 1, equation number 2 and equation number 3, can we say that since right hand sides are equal, left hand side will also be equal? So let us write down AP upon PB is equal to AQ upon QC from 1, 2 and 3. Okay, clear students? So here we have completed how is the basic proportionality, how we all are going to solve a basic proportionality theorem. Okay, now we will start with converse of basic proportionality theorem. Okay students, tell me, what do you mean by converse? Converse means, if I tell you in Hindi, it is the ulta of the basic proportionality theorem. What do you mean by converse? Means ulta, opposite. Converse means opposite. So what is this converse of BPT? Okay, now in converse of BPT, remember whatever was the given for basic proportionality theorem will become to prove over here, and whatever was to prove will become given in this basic proportionality theorem. Okay, in this converse of basic proportionality theorem, I'm just going to teach you all the concepts, means how you all are going to apply this theorem, that is converse of basic proportionality theorem. Theorem we'll be learning in the next video. Okay, so let us see what the statement of converse of basic proportionality theorem says. What does it say? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay, with the help of this statement, if we try to make a figure, what figure will we get? It will be similar to the basic proportionality theorem figure. Okay, so if we make this figure, what are they saying you? If a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. I had already told you in the previous theorem that whatever is there after if will become your given, and whatever is there after then will become your to proof. So with the help of that, can you tell me, students, what is given and to prove in this converse of basic proportionality theorem? Yeah, please try. What are they saying? A line divides two sides of a triangle in same ratio. Means this is the line. This line is dividing this side, AB and AC. In which ratio? Same ratio. So what will be the ratio? AP upon PB is equal to AQ upon QC. This will become your given. Okay. I have always told you that whenever you are solving any sum in geometry, you will always have to follow the steps. So, whenever you are using this concept, that is converse of basic proportionality theorem, first you will write down in whatever triangle it is given, in triangle ABC, then you will write down which line is parallel to which side of a triangle. That is, line L is parallel to side BC. This is to prove, this is not given. So what is given? That this line is intersecting the other two sides. That is, which side? AB and AC at two distinct points. And which is the point? P and Q. And what else is given? The ratios are same. That is, AP upon PB is equal to AQ upon QC. And therefore we can say that the lines are parallel. That is, line L is parallel to side BC. Clear, students? Means in basic proportionality theorem, lines are parallel is given. And what we had to prove? That they are ratios. Which ratio? That the line which is dividing the other two sides, their ratios are same. And whereas in converse of BPT, the ratios are same is given. And therefore the lines are parallel. Clear? So whenever you are using basic proportionality theorem, how would you go about? First, basic, not converse. Please don't get confused. So first you will write down in triangle, whatever the triangle's name is. Then you will write down which line is parallel to which side of a triangle. Then you will write down this upon this is equal to this upon this. And what will be the reason? Reason is basic proportionality theorem. And if in the question it is given that the ratios are same, then you will write, if the ratios are same, then the lines will be parallel. Reason will be converse of basic proportionality theorem. Okay, so whenever in the question it is said that the lines are parallel, then you can use basic proportionality theorem. But if it is said that the ratios are same, then you will use converse of basic proportionality and write down, therefore the lines will be parallel. Okay, please be important which reason when you will use, otherwise you will lose your marks. Okay, so having completed what is basic proportionality theorem, what is converse of basic proportionality theorem, let us now go to one. So students, let us now see what does the property of an angle bisector of a triangle states and when can this property be used. Okay, let us see the statement of this theorem. What is the statement of this theorem? The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Okay, so for this theorem, we need a triangle and we need a bisector of any one angle of a triangle. So let us take a triangle and a bisector of any one angle of that triangle. Okay, the bisector of an angle of a triangle divides the side opposite to the angle. Okay, if this is an angle, that is angle B, can you all tell me what is the side opposite to this angle? Yes, it is side AC. So what does this property say? That this angle bisector is dividing this side in the ratio of the remaining two sides. Means it says that AD upon DC is equal to AB upon BC. So you can use this property whenever you have a triangle and whenever you have an angle bisector of any one angle of that triangle. Okay, students, so whenever you see in your question any triangle and an angle bisector of any angle of that triangle, then you can use this property. But while using the property, presentation is very important. So what you will write? First, you will write down the triangle, name of the triangle, then you will write down which ray bisects which angle, and then you will write down the property. What does it say? That AD upon DC is equal to AB upon BC. So students, we have seen when we use basic proportionality theorem, when we use converse of basic proportionality theorem, when are we going to use property of an angle bisector of a triangle. Now let us see one more thing. Now let us see when are we going to use the ratio of the intercepts made on a transversal by three parallel lines. What are they saying you? The ratio of the intercepts made on a transversal by three parallel lines. What does the statement of this property states? What does they say? The ratio of the intercepts made on a transversal by three parallel line is equal to the ratio of the corresponding intercepts made on any other transversal by the same parallel line. Okay, the ratio of the intercepts made on a transversal by three parallel line. How many parallel line? Three. So what you need first, you need three parallel lines. Okay, three lines which are parallel to each other. Thereafter you will need two transversal. What you will need? True transversal such that both the transversal are intersecting all the three parallel line. So you need somewhat this type of figure. So whenever you have three parallel line, here you can see this line L, line M and line N are parallel to each other. And this is the transversal. That is T1 and T2 are the transversal. Can you see this transversal is intersecting all the three lines, and even this transversal is intersecting all the three parallel line. Whenever you have such type of figure, what does this theorem say? It says that the ratio of the corresponding intercepts made on the other transversal by the same parallel line. What does it say? That these ratios, if I consider only one transversal, so what will be the ratio? AB upon BC. And now if I consider this transversal, what are the ratio? PQ upon QR. So what does this property say? That whenever you have three parallel line and two transversal, then these transversal will intersect all these three lines in the same ratio. That is, you will get AB upon BC will be equal to PQ upon QR. So how will you present this? First you will write down, you will state that these are parallel lines and these are the transversal, and this transversal is intersecting this line at points A, B and C, and this transversal is intersecting line L, M and N at point P, Q and R. So what you will write down? Line L is parallel to line M is parallel to line N, and transversal T1 intersects the line in point A, B and C, whereas transversal T2 will intersect the lines in point P, Q and R. Then or therefore we can say that AB upon BC is equal to PQ upon QR. Okay, now we have said that these ratios are same. That is AB upon BC is equal to PQ upon QR. There is two more possibilities. You can even say AC upon BC will be equal to PR upon QR. Okay, now if you are taking in the numerator AC, that is this segment. So in the right hand side of the numerator you will take PR and nothing else. Please be careful. If you are taking AC, then on the right hand side it will be PR. If you are taking BC, then on the right hand side it will be QR. If you are taking AB, then it will be PQ. So you have to be very careful when you are using it. So you can even use it as AC upon BC is equal to PR upon QR, whereas you can also say it as AC upon AB is equal to PR upon PQ. These are the two ways in which more you can use. So we have learned when you are going to use basic proportionality theorem, when you are going to use converse of basic proportionality theorem, when you are going to use property of an angle bisector of theorem, and when you are going to use this property. So when you are going to use basic proportionality theorem, whenever you have a triangle and a line parallel to a side of a triangle. Then when are you going to use converse? When it is given that the ratios of the triangles are same. And when are you going to use property of an angle bisector of a triangle? When you have a triangle and an angle bisector of any one angle of a triangle. Whereas when are you going to use this theorem? Whenever you have three parallel lines and two transversal, and those two transversal are intersecting all the three parallel line. Clear, students? Thank you for watching this video.